we were comparing online transaction processing and batch processing, and we said under what situations we use batch processing and under what situations we use online processing. The major difference between online transaction processing and batch processing, as I pointed out, was that in online transaction processing we have to emphasize response time. While the person is waiting, the person is being serviced. So, the response must be very fast. Whereas, in batch processing, because it is done periodically, the more important criterion from the point of view of the person who is managing the server is to get throughput, that is, as many programs as possible in a given unit of time one should be able to run, and this effectively reduces the idle time of the computer, and reduced idle time is what effectively gives, you might say, the best performance for the cost of the machine which has been invested. There is a lot of confusion in general in people's mind between what is online transaction processing and what is real time processing. It is in fact very often used synonymously, but it is not correct to use real time processing and online processing as synonymous, because in real time processing the primary aim is to be able to meet a certain deadline in finishing a particular task. If the deadline is missed, then the task has to be aborted. That means it does not work properly. To give a simple example, if you are actually controlling the motion of a space vehicle, you got to be able to give commands to a space vehicle in real time while it is moving. Similarly, if you are having a system to control the landing of an aircraft, the landing of the aircraft nowadays is in fact controlled by an onboard computer, and the landing is a very short period because the plane is coming in at a very fast rate. So, you have to be able to give correct commands in terms of the height, what height he should come, what speed he should have for him to land correctly. If there is an error or if there is a delay, particularly if there is a delay, then there could be an air crash. So, in real time processing, not meeting the deadline can mean the difference between life and death. So, the actual constraints or requirements on real time systems is much more severe than on online systems. Online systems does not really matter if a customer has to wait for 1 extra minute. Only thing is the customer will become a little impatient, but it does not really mean any life or death kind of a problem. So, online processing is somewhat simpler than real time processing. Another point one should realize is, with the coming of personal computers in large numbers and with the coming of networks, both local area networks within organizations and the internet connecting networks, local networks to a worldwide network of computers, such a system where more or less everything is connected to everything else, most of the systems are really online systems, primarily because the connection is available, and online systems have become more or less very common and batch is used only when you have a lot of periodicities, there is once in a while processing. For instance, all inquiry systems are online. And if you want to do any inquiry on your bank account, or if you want to make an inquiry about ticket status in a train or a bus, all these things are online, not real time of course. And whereas batch systems are always periodic. I am just re-emphasizing the point that it is periodic. The periodicity may vary from depending upon the application. It can be once a month like in payroll, can be once a year like in CET, or it can be once a day. If you are at the end of the day, you try to find out how much of goods are sold, say in a retail shop, or how much of money was collected at the end of the day. So, these are periodic. So, the periodicity depends upon the application. Now, we have been talking about the three broad classifications of information systems. We said that the routine data processing system is the one which is very commonly used, and then management information systems are the ones which pay for themselves. In other words, they are the ones which lead to profit in the organization, and decision support systems which are used by top management for strategic decision making. So, the operational information comes from routine data processing, tactical information comes from MIS or management information systems, and strategic information comes from decision support systems. Now, if you look at the MIS, the input to MIS is always the output of the routine data processing. In other words, routine data processing is necessary in order to be able to do anything further with a management information system. In the earlier days of computers, when computers were slow and computers are also very restricted in terms of memory and so on, many organizations stopped data processing with only routine data processing, because the machines are not powerful enough to run more complex programs because of lack of memory and so on. And also data collection and data storage in the 60s and 70s was quite small, because the storage devices which are available, in fact the maximum disk size I remember in the early 70s was only 2 megabytes, and today nobody talks about anything like less than 80 gigabytes on a PC. So, storage size have increased considerably now, and cost has not gone up, and this has made it much more important to emphasize MIS, because processing power is no more a constraint. The only constraint is your own method of imagining, coming up with a proper idea of working. The operational information, as I said, leads to the raw material on which you can work to get the MIS or tactical decisions. Let me take a very simple example. Some years ago, I was consulting for a truck company, and the truck company, they were producing a lot of trucks as usual, of course that is what they do, and they are actually also keeping record of how many trucks are produced every day, and after the trucks are produced, they also are producing some spare parts for the trucks, because unless there are spare parts available, like for instance shock absorbers, springs, pistons and so on, spare parts become an essential part of the sale of a truck. If a truck company has a reputation that their spare parts are available with no difficulty at all, then the sales of the truck will increase. If on the other hand you find that you bought a truck and you can't get a spare part easily, then naturally people prefer the truck where the spare parts as well as service centers are available in plenty. So, in fact, most of the current companies have realized that, and there are both workshops for repairing your cars and trucks and so on, as well as the workshops stock a lot of spare parts. So, the company found that spare parts were somewhat, even though they had an idea of how much a spare part was being consumed, the production was in a different time and it was costing more money to produce. Further, apart from that, in most of these areas, whether it be motor cars or trucks or even computers, when you buy the product like a computer or a truck or a motor car, they try to sell you and keep the cost very competitive with all the competitors. But when it comes to spare parts, that is where they make their money. The spare parts are the ones which are quite expensive, and so the profitability on spare parts is normally higher than the profitability on the truck itself. So, based on their operations data, they are computing the profitability of spare parts versus profitability of trucks. They found that for the same amount of money invested, spare parts is giving more profit than trucks. So, the question which immediately arose is that in order to make sure that I do not run out of spare parts, if I run out of spare parts when it is needed by a workshop, then spurious spare parts will come into the market, and not only will you lose your money, but you will also lose your reputation, because spurious spare parts will not have the same strength or same quality as the spare parts you produce. So, one of the important things the company had to do was to predict, and prediction is based on what? The past. So, they look at the consumption over the period or a period of time, and then they project the consumption and say what the consumption will be at different periodic intervals. So, they use an operations research technique, which is primarily a method of using mathematics to do things like prediction, statistical study and so on. So, they have a prediction of these things, and then they decided that there is no point in having a separate time for making spare parts. Why not combine making the spare parts along with the making of the parts for the assembly line? In other words, they effectively try to make some of these parts which are made in the company, and they make those parts as an extra set along with the production of the regular items which go into the truck. So, there is no separate requirement of schedules and so on. The same schedule is used, but you have larger number coming out. Some of it goes into the truck, some of it goes into the spare parts pool. So, this way they are able to optimize the production of spare parts and also not overstock or understock, get the correct level. So, the probability of not having a spare part is made low, and effectively the profitability really went up, and they also calculated what the profitability will be with an MIS. So, to convince the management that there is a right method of doing things, they had to run all these simulations on the computer with the operational real operational data which they had collected over a period of time, and then show graphs and curves and so on to the managers to convince them that is a good policy. So, the policy changes in a company take place because of the fact that the operational information was used effectively to improve the method of working of the company. This is one example. Many such examples. One more example I would take is that of inventory. Inventory control is one of the major applications of MIS, where the two basic ideas in inventory control is you should be able to keep the, like if you are running say if you are running a store like a food mart or even a medical shop, it is important to be able to not lose customers because you didn't stock their item, and you should not overstock. If you overstock, of course things are lost. I mean things are in the shelf without making any money. That means you are losing money on whatever you invested. So, it is very important to be able to decide the time or the volume of a particular product at which time you got to reorder. So, when you go that is called reorder point, that is you go on finding out the current stock position of some particular item, and the stock position is getting to a limit, you reorder, and the amount of quantity to be reordered depends very much on the, as I said, the time taken to get the goods into your shop, other unforeseen reasons and so on. And again OR or operational research techniques are used based on past data to be able to come up with a reasonable reorder point and the reorder quantity, so that the overall the particular shop does not run out of the items, neither do they overstock. So, this is the primary aim. So, these are the some typical examples of the use of MIS. I can go on and on with lot more examples, but I made the point, namely that the raw material is input, and input you have to correct the right input. You will not correct the right input unless you know what you are looking for. So, it is all the more important to be able to look at what the ultimate objectives are to try to get the necessary data in the operational information system. But MIS by and large is a very important area of application. And there are other decision support systems one level beyond, that is done by the, as I said, the top management, and it is very unstructured and very difficult to obtain precise information because of the fact that, as I was saying earlier, many of these decisions are based on your general knowledge and your knowledge of the field and what is going on and things like that, and also depends upon the what kind of a strategy you want to take, and you have to again use analytical and simulation models to be able to come up with a reasonable decision support system. Actually, there are many aids which are used in decision support systems to conceptualize the problem through graphs, animation, etc., to understand what it is. And you also use archival data to infer trends. And there are some artificial intelligence rules also you use. What I mean is certain kind of heuristic rules or rules which you work on based on your assumption that this may take place. Let me give an example of what this implies. Very often in decision support systems we use a what if question. What is meant by what if question is, suppose you have a choice that you are running a retail shop and you want to find out whether it is worthwhile starting another shop in a new area, and you want to find out what the investments will be on that and what you expect to be return on investments, whether starting this is going to be profitable or not. So, the what if question is, if I did not start it, will some other competitor come there and start and I will lose my potential customers. If I do start, am I going to be profitable right away or am I going to be profitable a little later? Is it better to preempt and do it earlier than your competitor does? So, these are questions which are what are known as what if questions. And what if questions in fact are aided by the use of a very common tool in the Microsoft Office, namely a spreadsheet. In spreadsheet you have a number of rows and columns, you can put, as you know, formally, and you can change values around, percentages around and so on, and instantly you will find the effect of that. In other words, you can use spreadsheets to ask questions like, if the sales goes up by this amount, how much will the profitability go up? Or if you are wanting the pricing policy, pricing policy is very important. Like for instance, if a book publisher publishes a book, at what price should he sell it? If he sells it at a very high cost, maybe the number of people who buy will be small, but the profit on each book will be quite large. But if it is a huge sales, because the cost is reasonably low, then the total amount of profit I make because of the volume will be very high. So, the pricing decision of most products is crucial. In fact, it is a very interesting area, and many companies intentionally price their products very high to give the feeling among people that their product is superior. It may not be at all, but then there is a certain snob value in thinking that I bought a very expensive piece of item. It may not have all that high quality, but it is again they are catering to a certain segment of the market which has money to throw away. So, these are pricing decisions which a decision support system allows you to take in terms of getting a statistical idea of what is the population which you are catering to. Is there a population which has got disposable income, high income, which they can essentially spend on expensive items and so on. In fact, one of the reasons why many of the multinationals are companies selling consumer products like shoes and bags and so on are coming into India is that we have now a fairly large middle class of almost 200 million people who have reasonably good disposable income, and so there is a possibility of making some profit on this income. So, there is another reason why they do that. Another kind of a important tool used in decision support systems and also in MIS is called data mining. What is data mining? See, we collect data over a large period of time, routine data. Now huge disks are available, terabytes worth of disks are available. So huge amount of data can be collected and stored and organized and so on. And previously all that so called archival data was just kept for legal purposes. That means over a period of time auditors may come and check your what happened to the company, and they may like to look at the archival data. So it is primarily used as historical data, used only when some auditors come around and so on. That the reason was, in the earlier days only tapes are available for archiving, and tapes are painfully difficult to process because they are sequentially data is stored, whereas now terabytes can be stored on disks. There are so called disk networks of storage devices giving you terabytes of data. So on disks you can access data in a much more easy way through indexing and so on. So searching a disk and getting some actual processing based on the search rules becomes feasible, which is not feasible earlier. So data mining has come in its own because of this huge increase in disk sizes. So you create some hypothetical rules, you guess some hypothetical rules and try to see whether those rules are really valid or invalid. For instance, a manager or of a railway system may know through experience over years that the traffic on certain routes is very high, and there is also seasonal change in traffic pattern. That there is, in summer the traffic goes up very much, in Deepavali time it goes up, Dussehra time it goes up and so on. But to actually verify it, the operational data can be found out to see how many people are there in the waiting list. It's a huge waiting list. That means all those people wanted to go, but they didn't go, they couldn't go because of non-availability of seats, and so they took some alternate transport. Maybe a bus they went by, or if they are richer they went by plane. So you have lost your clientele. But this is only a hunch. So based on data mining, they can formulate rules saying that over this period a traffic is expected to be this much, and compare their rules with the real fact based on data which has been collected, and the rules adhere to when facts kind of match, then you know that this rule can be used and you can take an action, like for instance you can increase the number of sleeper coaches during that time and so on. Or you can also take other kinds of decisions, like for instance recently what has happened is that many budget airlines have come and they reduce the cost of air tickets, and they are trying to almost compete with the second AC 2-tier with the trains. So the railways got a little jittery, saying that our clientele is being lost to competing carrier. So there are two ways of solving this problem. One way of solving the problem is of course to reduce your AC compartments, but then you make a lot of profit on those, so there is no point in reducing. Other is to reduce the price. So to some extent they have reduced the price to try to make more people come, and sometimes they find that in spite of the reduction of the price, based on their data collected in operational with the operational information system, which is actually the reservation data, that lots of berths are empty in second AC, but there are big waiting list for sleeper. So, what the minister said as a strategic decision is that we will upgrade, that is, people who are kind of a frequent traveler by train, I would like to give him a little bonus, and instead of that those seats going empty, I will upgrade him, send him to the second AC, and those empty seats in the sleeper can be used by the paid people in the waiting list. So, going empty means no money, but going with some passengers means some profit. So, it also gives a good feeling among travelers that if I frequently travel by train, I get some bonus. So, this kind of a strategic decision is taken based on data collected in the recent past. If the same question you asked 5 years ago to the railways, they will say what nonsense are you talking about, because everything was going full. Only when the planes came and started competing, then this problem arose. And so, the point is that strategic decisions improve the profitability, and it is actually comes out of data mining, and some of tactical decisions also come out of data mining, looking at what happened, like the spare parts question I pointed out, inventory and so on, and a lot of things are come out of data mining. So, a whole lot of what if questions, what if the rule is correct, what would be the data like, and that can be kind of predicted. So, this is about waiting list and increase in sleeper coaches. I gave an example which is essentially put in this transparency. The most interesting point is sometimes unexpected results come out from the analysis of archival data. If something comes out unexpected, then it is a lot more valuable, because you never guessed it, but it gave valuable information to you. So, very often unexpected results do lead to new marketing strategies. And one interesting example of this is in terms of the data the marketing data which people collected over a period of time about the demand for certain types of consumer items in rural and semi-urban areas where people do not have that much of disposable income, but they still aspire to buy some of these new items like shampoo, like toothpaste and stuff like that. So, the strategy which was taken was that make small sachets of shampoo or small tubes of toothpaste, so that the one time expense is quite low and people will start buying. Once they buy, the volume is very high, so profitability will go high. So, this is an unexpected thing. In other words, people are ignoring the so called poor people, but the poor people have a lot of money to spend also, provided you give them the opportunity to spend it. Okay. So, this is the kind of unexpected result which comes out of analysis of archival data and also a lot of marketing intelligence as well as certain amount of strategic ideas. So, in this module we have laid the groundwork for the design of generally information systems for use by organizations, and I talked about various types of information systems and functions of various functional division of organizations. So we have some kind of an overview now of what organizations are like, how do they function, what kind of information are they looking for, and what types of information can lead to good operations as well as good profit for the company. So these are very, very important parts when you think about an overview of the design. These transparencies are also available on the website which goes along with this course. So you don't have to really copy down these things, it's there in the website for you. And over and above this, in the web support material for this course, there are also lots of examples, exercises, solved examples, some notes, some multiple choice questions and so on. And I will urge you to go and look at the website and go through this material in the website, preferably as you are listening to the lecture, but at least if not at the same time, at least to revise or go later and look at it, so that you know, you understand better the lecture, or in fact it is preferable to kind of read it beforehand before you come to the lecture. But I could say that, but nobody does it. I mean, nobody would read ahead of time. They even reading after the event is important, but many students do not do that because they only study at the end of the semester at the exam time. But then if you want to really learn the subject, you got to continuously also look at the web, try to solve the problems and so on. That way you will learn the subject. Learning is a lot more important than passing an examination. Okay. Anyhow, so the having finished this module, I am going on to the next module, and the next module is about how to get into the methodology of designing a system, as analyzing and designing a system, which is the core of this course. So the core itself, the course itself is named Systems Analysis and Design. So the core of this subject we are really starting now, and systems analysis and design, we are going to look at number of issues. First I will talk about so called steps in the life cycle of a systems analysis and design. Now the question is, what do I really mean by life cycle? Life cycle is a common terminology which is used in books on software engineering as well as systems analysis and design and MIS and all that. All the books use this. And if you may wonder why this terminology is used. Actually, this terminology is borrowed from, in fact, the life cycle of a human being. You know, every human being has certain stages in his life. There is a infancy, there is a childhood part, then you go to school, then you go to high school and +2, then you go to college, then you go to work, and then you retire. Inevitably also you will also die. Okay. So there are stages in the life of any person. Similarly, there are stages in a design of a system. is also stages in the life of the system. No system is going to be alive for an indefinite period. Just like human beings are mortal, computer based systems are also mortal. The reason why computer based systems are mortal, that means what is meant by mortal in this case is that a working system which has been working for some years, they may decide to throw it away and put a new system, and so the old system has died. An old system will die when the people find that its usefulness is no more there, and it may arise because of many reasons, like system may be reasonably all right, but may be implemented in computers which are completely obsolete, and you can't get any replacement spare parts for it. So, you are perforce required to upgrade your computer system to a new system, and concomitantly also come up with a new systems analysis cycle which is appropriate for the new environment created by the new system. I know many companies which do not want to do this change, mainly because it is very expensive to change, and also it is painful because you go again through all the bugs, all the difficulties and so on. In fact, one of my cousins who is working in America, she said that well, I am working in a banking system, we are still using PDP-11. PDP-11 was a machine which was built in maybe late 60s, early 70s. It's not made anymore. So then I asked why is the bank still trying to use the same system? They said, well, top managers are quite comfortable with it, and programs are running, and we are getting all our work done anyhow. So the question they ask is, if I am going to invest more money, am I going to get some return? And I have to go through a lot of pain in this changing. Is it worth it? So these are points which one has to consider in the long run. By and large, it turns out that managers are conservative. They say, if things are working, let it work. Why not this? Why disturb? And why as I say, why wake up a sleeping dog? Okay, let it just let it go on routinely. And unfortunately, some of these things which are routinely going on will not lead to a certain better profitability. They will be forced to change only when they suddenly find that a competition has come up with better information system, and they are able to cater to their customers better and are making higher profit. So then they will be woken up from their slumber or their sleep, you might, and then it will come to their attention that is necessary to change, even if it is painful. So the point is, a life cycle is number of stages, and each stage certain tasks are performed by systems analyst. The reason why we talk about the life cycle is because designing an information system for an organization is a very complex job. It requires a lot of conversations with people, determining the requirements and so on. It is a very long drawn out job, and very often it takes a very long time to come up with a good system. So whenever you have a very complex system, you should be able to divide that complex system into smaller parts and design each part somewhat separately. In programming, they call it modular design. In other words, some people also use the term divide and conquer. If a very complex problem is there, divide it. If I divide it into smaller parts, each one becomes simpler to solve. So, I will be able to look at the simpler smaller part and solve it better. So, divide and conquer or modular design, you also should know where to break it up. You can't arbitrarily break it up. So, the logical divisions had to be looked at. Each step, when you divide this big complex task into smaller parts, must have a logical beginning and a logical end. And so, you should be able to say when that step has started, when it is ended. And apart from the fact that it is ended, the time it ends, you have to be able to say whether it successfully ended. And at the end of each step, you have to assess progress. That is, in other words, you gave a certain amount of time for the whole project. You may have given something like, say, 4 months to finish a project. And if there are 8 steps, you may have given some earlier, some time chart for each part. And after, as soon as you finish that part, you compare the time you have taken with the projected time. And if the projected time is much lower than the time you actually took, that means there is a slippage in your schedule. You have delayed. So, somewhere else I have to make up to be able to make the ultimate deadline. So, I may have to put more people on it or have to follow a different path. So, in other words, it is important to be able to assess progress periodically. Otherwise, you end up in a situation where deadlines all slip, everybody becomes unhappy, you work long hours without really being very productive. So, these things had to be prevented. And the method which one has to follow is also that when you are doing this division, divide and conquer, or divide a particular long process into smaller processes, you have to assign people with special competence in that area. If it is a design stage where you are going to design, people who have design competence in that area, like for instance, we are doing for an insurance company, if the designer has done it for other insurance companies which are similar, then you assign that person to this, because he will take lesser time, his learning time will be lower. So, you have to assign correct people to the correct job and also at the right time. You have to allocate the proper financial resources for each step. So, these steps are necessary to allocate resources, both human and financial. So, we are going to look at 9 different steps in this analysis, and the 9 steps which I am going to use are not sacred. What I mean by it is not sacred, not every author will use 9 steps, some use 7 steps or even less. But in my view, 9 steps are required, and each step is somewhat independent of the other step. When you design a system step by step and go along, some software engineering books call this kind of a design, where you go step by step by step, as a waterfall model. These are all jargon. I mean, What it really means is that you have a step by step solution. When you finish one step before you go to the second step. It's called waterfall model because waterfalls in a step by step might say, okay. But whatever it is, there is terminology is stuck. When sometime when I first heard the term waterfall model, I didn't know what it was. Then I had to ask what it is, and then the guy said step by step. Which is why do you use the term waterfall? But that is essentially makes him feel superior because I have to ask what it is. See, so it turns out that many of the jargon terms in computing are invented for a particular purpose, and very often when those terms are used to lay people or even to people who are new to the field, you suddenly feel you don't know it, but actually the concepts are extremely simple. Now the fashionable thing they say is that waterfall model is not the right model. We need to have a spiral model. Now what is the big spiral model and what is it, how is it different from the so-called waterfall model? The whole idea is that if you go step by step and don't review progress at any given step, at the end if you come up with a mistake, then you have to retrace everything. So instead of that, the common sense dictates that as soon as I finish some part and the second part, I revisit the first part. I just don't go with the third part. So I revisit the first part and see if any modification is required in part 1 or step 1, having done step 2, in order to be able to do step 3 better. So you assess progress, you modify, and you proceed. There is a certain kind of feedback at every step you try to use, and these feedbacks essentially are, you might say, spiraling from one step to the other. Of course, you should not spiral forever. You should kind of decide when the spiral ends and go from step to step. But by and large, these are all jargon people use, but generally the ideas are fairly simple in terms of what this really means. And so we will look at this so-called 9 steps in the analysis and tasks performed in each step. The steps are requirement determination. I will first talk about the first 3 steps, and I will go on with other steps in the following talks. First step is called requirement determination. What is meant by requirement determination is that when a company wants to have an information system to improve their operations, there could be 2 types of situation one may encounter. One situation you may encounter is that there is a new nursing home which has started, and this nursing home wants to use computers to improve their operations. So you start from scratch. Then you can go and talk to the people there and try to find out what their requirements are. And before that, requirement determination means what is it that they require it for? Do they require it for admitting patients, allocating beds, or do they require it for diagnosis? Okay, or do they require it for teaching, to give some kind of computer aided lessons to the doctors who come there to update them? So the requirements may vary. Is it only allocation of beds, or do you also want to look at the pricing, how much to be charged, and creating a bill and billing customers and things like that. So, there are a number of possible requirements. Among these, you have to find out what is the important requirements which you have to determine. I will take an example, I mean a day-to-day example. Okay, you want to you suddenly your family says, let us go and build a house. Okay, let us build a house because I have a plot somewhere. Now, the requirement determination phase means, do I really build a house? Should I really build a house at this time, even though I have a plot? Or should I continue with where I am? Because I am quite comfortable where I am. It may be in the center of town, whereas my plot may be way out somewhere, where there is no transportation available. So, the requirement determination phase decides whether to build a house or not build a house, or to build a house at a later stage, postpone the issue. So, this kind of a thing companies also have to take, as do I do this now, do I need a computer based system for my nursing home, or my operations are not large enough to make it necessary to have machines, and I do not want to make the investment at this time. Okay. So, the decision at that time would be to either to go with it or not go with it, and even if I go with it, what aspect of it do I go with? That is determination. Specification is only after I determine. So, I will talk about specifications next time and talk about detail, because specifications are extremely important in any, before you do any design, particularly of an information system. And so, requirement specification is still an art, and we need to discuss it at fair lengths, which I will do next time.